All right, so let's dive straight in. We are going to be using Stack Overflow's Developer Survey to predict developer salaries. And if you're not familiar with Stack Overflow, it is a really common tech hub where people can ask their tech questions, answer other people's tech questions, and it's a really, really great resource to help you debug and to learn new programming concepts and ideas. And every year, Stack Overflow sends out this survey to people that use their site and puts together a pretty phenomenal report of the information. We are going to be looking at the 2023 data from them. That was the most recent data I could find that I I believed in the data source. The data source is directly from Stack Overflow's Kaggle page. So it's very valid data. And yeah, we're going to use machine learning from this survey data to see if we can predict a salary based on different factors like location and years of experience and tech tools. What tech tools are kind of correlated with higher salaries? We're going to find out. Okay, so let's dive straight in. We are here in the DataQuest app in our brand new project. Like I said, brand new, launched an hour ago, and this project is going to be free for you guys for the next week. And then it will be a premium project. So if you would like to complete this for free, you have until next Friday to do so. Okay, so the very first thing that we're going to do is load our libraries here. And I'm copying and pasting from my solution notebook so I can save some typing time. And we have pandas, numpy, matplotlib, and seaborn kind of as our data analysis and data visualization libraries. And then we have scikit-learn library imports for our train and test, our linear regression model, and then a couple of metrics that we'll use to evaluate how our model's performing. Let's go ahead and shift enter on my keyboard, make sure that runs. Okay, and it has run successfully. Now let's read in our data set. So I'm just creating a data frame called DF, and you'll notice the survey name, if you want to work locally, by the way, in the DataQuest app, if you right-click the CSV here, you should be able to download it, or you can download it directly from Stack Overflow on their Kaggle page. But you'll notice here that it says slim. The original data set includes almost 90,000 rows of information, which is too many to work with in a very quick way. So to keep things streamlined for you, we removed about half of the rows and about half of the columns from the original data set that had null values for our target variable and also had columns that weren't necessarily related to salary prediction because remember the Stack Overflow Developer Survey asks a ton of questions that aren't necessarily about salary. Some of them are about how often do you use Stack Overflow? What are some technologies you want to work with but haven't worked with yet? And those types of things aren't useful for this analysis. So if you do decide to download the dataset directly from the Kaggle page, be aware that you're going to need to do a little bit more data cleaning than I'm going to need to do here. So taking a look at our info method is my favorite way to get an overview of datasets. We can see that we have 48,000 entries and right now we have a total of 33 columns. And main branch, age, employment, remote work, years of coding, what languages people have worked with, going down AI tools that people have worked with, how much work experience they have, what professional technology, I think that's what that is, that they're using, what industry, and then our target variable is down here at the bottom, converted compensation yearly. So this is our salary. And converted comp yearly is normalized to US dollar. Developers from all over the world answered this survey. But just so that we don't have to account for exchange rates, we're going to be using the Stack Overflow provided USD conversion here. And we can also see our data types. Our data types, we have a lot of objects, and objects don't play nicely with machine learning because we need everything to be numeric in order to calculate. We're going to use linear regression, and in order to calculate how different things interact together, we need numbers. So a lot of our data cleaning steps today are going to be dealing with objects and how can we make them fit for machine learning. Because we have so many rows, even after this is the slimmed down data set, we're actually gonna not look at the df.head method yet. You're welcome to do that if you want, but we're gonna actually just start with things like this. Look at how many non-null values there are for AI dev have worked with. Compared to the 48,000 rows in our data set, we have a lot of missing values here. And maybe we actually have more columns to drop before we work on any data type conversions. So in our next cell here, we're going to calculate what is the percentage missing for each column in our data frame. And we can see here that we have two columns that are missing more than 50% of their values. We have AI dev'd have worked with, an AI tool currently using, missing 71% and 60% of valid data points here. That's a lot of data missing, and machine learning missing values don't work. So these are going to be rows or columns that we drop. You could consider some kind of imputation method, but imputation on something missing more than 50% of data is not a great idea. So these are going to be dropped. And in fact, there's a couple more columns we're going to drop. And I'm going to do a big copy paste here, but we'll go through line by line. So columns to drop. This whole cell is just reducing the number of columns we're going to be using. Benjamin, yes, your basics notebook should be empty. Basics is where you do your work. So if you do look on the side here, you'll see, I'll expand it out. You'll see that the solution notebook is available for you to reference, although I caution you to not do that. Start with basics.ipynb as the area where you write your code and peek at the solutions if you get stuck or need a reference. Okay, so we are going to extend the number of columns we're dropping here, learn code online, your personal operating system that you're using, a couple of metadata columns that aren't necessary for predicting salary. We're getting rid of a couple more columns with high missingness values, as well as office tools. So think of like Microsoft Word, great office tool, but probably not super indicative of salary. And I am going through this kind of quickly, and the reason why is when we have 48,000 rows and 33 columns, that's a lot of data for our model to try to calculate on. So we're reducing things a bit to make it easier on ourselves and easier on our model. So I'm culling our data basically. So now we're dropping our columns and we are reassigning to a data frame called df underscore cleaned. So let's take a look at what we have now. So we dropped 12 columns with this columns to drop code here. And we have 21 remaining columns. And let's take a quick overview of what these are. So main branch, age, employment, remote work, your education level, how you learned to code, and then some experience levels here, what developer type you are, what your organization size is. So if you're working for a very small company or a very large company, what country you're located in. And then these ones are going to be where we have to spend the majority of our data cleaning time because in the survey, people had check multi-select. So they said, okay, I've worked with Python, I've worked with SQL, I've worked with JavaScript. So these are going to be semicolon separated lists, and we're going to need to figure out what to do with these. What operating system you use professionally, and work experience, industry, and then our target variable here. All right. Now let's look at the head of our data frame. Okay, we have our remaining columns, and we can see a lot of string values here. Education level, bachelor's, some university, some college, how to learn to code, kind of some semicolon separated lists here. Dev type, we have senior executive, C-suite, works for a small company, it looks like. Languages people have worked with. So the main thing I'm seeing from this .head method is that we do in fact have so much string and object type values that we need to take care of. All right, and because missingness is important for machine learning, let's continue our missingness search and not just look at things that have 50% or more missing. Let's just see anything that has missing values. So industry, work experience, and then our worked with multi-selects, they do have some pretty substantial missing values here. So we're going to need to address those. Um, and then let's also look at our data types, like how many string object data types are remaining. Wow, we only have 2 float data types out of 21 columns right now. That's a lot to clean up. We got some cleaning to do. All right, all right. I'm gonna skip that. No, I'm not gonna skip that. We're gonna do that. Okay, so we're gonna look at how many unique values there are because sometimes in machine learning we can use one hot or dummies to convert a column into multiple columns with Boolean values. So is remote true or false? Is hybrid true or false? And those would each be a column. But that only works if it's a small number of unique values. So for some of our key columns here, like country, what type of developer they are, education level, unemployment, let's just see how many unique values there are using the nUnique method. Oh, I was on the wrong cell. Let's run this cell. There we go. Okay, and we can see that country has 171 unique values. For one hot encoding, that's way too many because we do not want to add 171 columns to our data frame. That would probably make our machine learning model cry. Dev type 33 unique values still is probably too much for using dummies here. So another candidate that we can't use that method on. We'll have to figure out a different strategy for converting dev type into numeric values. But education level has only 8 unique values, which is not too many. We're not gonna do one hot here, but we are going to use some ordinal encoding, which we'll talk about momentarily. And then employment, 14 unique values. Probably too many for one hot as well. Okay, now this is, I think, the most controversial line of code that we're going to write today. Because we started with so many rows in our data set, I'm being relentless in how much data I'm removing. If you want a next step for this project, go ahead and flag this line as an opportunity to do some further exploration because I decided, look, we have 48,000 rows. We're just going to remove anything that's null. Any row that has null values, get rid of it. So my homework for you is consider, are there imputation methods that you can use here? Is there nulls you can handle in a different way? Uh, I bet there are, but for my purposes, I decided to just drop anything that was null. And luckily, we have a pretty decent amount of data remaining. We have 16.4 thousand rows, down from our original 48,000. And I caution about this just because it could have introduced some kind of selection bias. For example, maybe someone who completes the survey fully with no missing values, maybe they are fundamentally a different type of person than someone who leaves missing values. And so we're missing salary information from the people who had the null values. That's very possible. But for this project, I decided to address it verbally and in my end notes for my notebook, but continue on with this method. And Ben, I'm seeing another question from you in chat. Would you mind sharing those questions in the Q&A box instead of the chat so I can address them towards the end? Okay, so now that we have a clean, cold data set, let's look at some summary statistics. We're still kind of in our exploratory phase. We're cleaning up as we go. And let's look at the describe method for our target variable, our compensation yearly salary. And our summary statistics are kind of ugly here because the numbers are so large, they're showing in scientific notation. There's a workaround to fix this, but I decided to just leave it as is. So we can see that our minimum salary is $1. And this is annual salary, so that's a little suspicious to me. Our maximum salary is pretty staggering, $10 million, which feels like it's probably an outlier to me, especially considering our mean and our median are different by about $2 million. Is that right? 2 million? No, that's too much. No, let me scientific notation convert here. Regardless, our mean and median are pretty off. I haven't had all my coffee yet. My apologies. But we can see our salaries, and we did a quick count here to show our very, very large salaries and our very, very small salaries. Very large salaries, I kind of arbitrarily picked over $500,000. We have 51 rows that are above $500,000 and 1,100 rows that are below $10,000. I picked these numbers arbitrarily. You could experiment with these and try different cutoffs, but the main goal of what this step is removing our extreme values to help our model understand the majority of our data points better. Okay, so let's look at our top and bottom salaries just because especially this maximum and this minimum are kind of weirding me out. So we're going to check the extreme values here. So our top 10 salaries, we have 10 million from New Zealand, 7 million from Canada, a couple more millions from different places around the world. And you know what? These are very likely correct real salaries. These are self-reported though. It's a survey, so people are just giving their their own salary information. So if I were to redo my code, I might consider a higher cutoff than 500,000 to keep some of these larger values in play. And then our bottom salaries, having a US dollar compensation of $1 per year seems like an issue to me, especially because these people are saying they're full stack developers with lots of years of code. This is likely a question misunderstanding or just a data entry error. So we're going to remove these values. And this is another area where if I were to go back and redo this, I might set a more generous threshold because as we'll see momentarily, big chunk of code incoming, don't panic, it's mostly for a visualization. When I cropped our extreme values here and reassigned it back to our df underscore model, I think that the minimum cutoff was too severe because our mean and median values are closer together now, but we can see in our visualization here that the skewed salary distribution looks like it should have a natural continuation still below $10,000. So that's another area I would recommend doing some more experimenting than what I did. And just to see if it could potentially be normally distributed if we log transformed our data, that's what this graph on the right is showing. Log transformations are really useful if you have skewed data like this. And we could see that, yeah, in general, the majority of salaries are kind of clustered in the center with some extremes towards the edges. For linear regression modeling, this is something to keep in mind that log transforming your data can potentially help your model understand what it's dealing with better. Okay, so we're starting to get a very good picture of our data here. But you know what's still nagging at us? If we scroll back up to our .head method, we still have a lot of object types to handle. And the object type we're going to handle right now applies to several columns at once. It's the have worked with columns. So we can see here language have worked with. This first person says HTML, CSS, JavaScript, and Python. This next person says Bash and Go. And these are all semicolon separated. And that is the same for language, database, platform, web frame, and tools. So a very quick, simple hypothesis of how to clean these columns is, okay, what if the number of tools you have listed, so this is 1, 2, 3, 4, 5, 6, 7, 7 tools versus 5 tools. Maybe the number of tools is correlated with salary. Wouldn't that be nice? Very quick, easy search and count for semicolons. So another big chunk of code incoming. But what we're doing here, and this is an example of how AI was very helpful in creating the solution for this project, is all of these rows of code are pretty repetitive. I just told AI to write it, and it did a very good job just for languages, databases, platforms, web frameworks, tools, and tech. Boom, it was done in a couple seconds. So what are we doing? We're counting the number of semicolons that are present in a cell, and we're adding 1 to it because semicolons will always be 1 less than the list length. And this only works because we removed all of the null values. If we hadn't removed the null values, we'd be introducing potentially an extra number for people who said they hadn't worked with any tools. So we're doing that for every one of our have worked with columns and creating a new column for it. So instead of web frame have worked with, now we're going to have a new column called the number of web frames that they've worked with. And we are also going to do a total number of skills that adds all of the individual numbers together. And we're going to do a quick correlation. So looking at our output here, number of languages, min value of 1 makes sense because we removed all of our nulls. Max value of 41. Someone's worked with 41 programming languages. Wow. And then our mean and our medians across the board seem relatively fine, pretty close together. Nothing outrageous here, which tells me that we don't have any extreme outliers. And then our total skills distribution, um, pretty similar story there. Now correlation. This is saying how correlated is the number of tools with your salary. So testing our hypothesis a little bit here that the more tools you know, the higher your salary is going to be, and vice versa. And not stellar results. The number of tools has the highest correlation with 11%, which is still a very, very, very weak correlation. And unfortunately, if this was how we decided to handle our object column type conversion, we're losing so much granularity because we don't know what the exact tools or languages are that are influencing salary. We just have a number. So I left this part in to show you my exploration, but this is not the, what's the word I'm looking for? Not the strategy that we're going to end up using. The strategy that we're going to end up using is actually looking back at our original have worked with columns and looking at some of the top values. And we're using a method called explode here, combined with splitting on those semicolon separators. And let's just take a peek at what are the value counts for some of our top results. And we can see here that language have worked with the top results by far: JavaScript, SQL, HTML, CSS, TypeScript, Python, some big heavy hitters here. And then Swift and Groovy, Lua, smaller values. And then databases, Postgres, MySQL, Redis are kind of the top results here. Top platforms, AWS, Azure, Google Cloud, so our cloud computing platforms here. And so this feels like it's more granular, but potentially really, really valuable because at the end of the day, we want to know what influences higher versus lower salaries. And this feels very rich for providing information to our end users, right? And this is another spot where you have some creativity and flexibility. I went with, as you'll see, I went with several different languages and tools to build into my model, but yours might be different than mine. So the following cell is not the only way to do this. And another big chunk of code incoming. Trying to decide how much. Okay, we're just gonna do this. This was phenomenally helpful to get AI support with. Don't panic. Basically, what we're doing here is we are adding new columns. That's a Boolean value of, does this row say that they have used Rust? Yes or no. Does this row say that they've used Go? Yes or no. Scala, Kotlin, and Swift? Yes or no. Python, JavaScript, TypeScript? Yes or no. And so on and so forth. And you can see that this is so much text that I would have had to manually type, and it would have been really tedious, really time consuming. But AI was able to do all of this based on the languages I told it to use. And just there was the code in one go, right? So we're doing that. We're creating about 30 new columns here. And that's okay because these columns are going to be numeric, Boolean values, right? That our machine learning model will be able to handle very, very well. All right, and now we're going to look at some correlations just to see, like, is this method any better? Spoiler, it's not, but I think the value is better. So what are we doing here? We are creating a new correlation matrix. We're going to print the correlations, and then we're dropping the original have worked with because they're object types. They're not going to be useful for our machine learning model. And then we're also dropping our hypothesis of just adding up the number of tools because the correlations there weren't very strong. Okay, now let's look at the correlations here. So based on our new Boolean has this skill or not columns, the highest correlation with salary is Terraform, followed by AWS, Kubernetes, Go, Rust, Python. And we are getting like, none of these are very, very strong correlations. Some of these are, in fact, negligible correlations. But you don't necessarily need to remove or keep a feature, which is a column, just strictly based on correlation with the target variable. So I decided to keep all of these in my machine learning model because it does give our model a lot more information. And just a quick little summary here. We can see now our feature types. We have integers, objects, and floats. We still have objects. We do still have objects. We'll take care of those next. In fact, let's take a quick peek at what those objects might be, looking at the info method. So we have all of our new columns here that are all integers, great. But our starting columns, age, employment, we haven't taken care of those yet. So that's up next. So we're going to pull out our object types and call them categorical columns. And we're going to look at the number of unique values for each of those to see if there are one-hot encoding opportunities. Okay. A lot of output here, but all very useful output. So we have two unique values for main branch, whether you're a developer by profession or you just write some code sometimes. This is going to be a great candidate for converting into a Boolean. Age has 8 unique values, and we can see that there's some kind of ordering here, right? Someone who's under 18 is younger than someone who is 18 to 24 is younger than, and so on and so forth. So we're going to do some ordinal encoding for this. Employment, we have 10 unique types, but we see a lot of overlap. So there's employed full-time, and then there's employed full-time and independent contractor. And so we're going to clean this up a little bit too, just to have fewer combinations. Remote work, great candidate for one hot. Ed level, 8 unique values, but there is once again some kind of ordering here where primary elementary school is going to come before secondary school, which is going to come before associate, and so on and so forth. So we're going to ordinal encode this as well. Learn to code, 554 unique values. Holy smokes, that's too many. And I made the decision to just drop this column because it's a lot of parsing. And I just didn't think it was going to be super, super valuable for our model. Years of code is 52 unique values, but we can see that in general, they should be a number. So this one is most likely an object column because of something like under a year of experience or unknown or something like that. So we're going to coerce this column to be numeric so that anything that isn't numeric is just going to turn into a null. Same thing with years of code, 51 unique values. They should be all numeric. Dev type, 33 unique values. We're going to consider what we want to do with this. We could one-hot this, but it's a lot of columns. Org size is another one for ordinal encoding because there's a hierarchy. If you have 2 to 9 employees, that's going to be a smaller value than 10 to 19, and so on and so forth. Country, 140 unique values. We are going to keep the top N values and then cluster the rest into a group called other. And then we're going to one-hot this. Operating system, 947 unique values. That's too many. So we're going to figure out what to do with this. And then AI select, 3 unique values, that's okay. Industry, 12 unique values, that's okay. So we have a plan now for how to turn all of our object columns into numerics. So I'm going to share the code for each of those one at a time. So we're going to drop the learn code and professional operating system columns because they were just too fragmented for us to have a good strategy to transform. The next one, we're going to ordinal encode our years, our age, our education level, and I thought we were also ordinal encoding org size. Um, I did this a little later on. I don't know why. I'm going to go ahead and add that in here. Yeah. So all of these are going to get ordinal encoded where the smallest value is going to correspond with the smallest amount, and so on and so forth. If someone said that they prefer not to say, we're going to assign them to the median value here. And the median value is 25 to 34. Okay, so after ordinal encoding, what was our next method? We're going to simplify with a little bit of mapping here. Okay, and our simplification is we're going to simplify employment because remember, employment had a lot of different types, but we're basically going to use a if statement to say if it's null, unknown, and there shouldn't be null values, but you always want to like have that catch-all. And then we're going from biggest to smallest. So next thing we're checking for is if they say they're full-time, we're going to say that's their answer. And if they don't have, or if they're full-time and independent, because those two things kind of are different and important together. And then we're going to look just at full-time. And then if they're not either of those, are they a contractor? And after that, are they part-time? So we're simplifying based on importance here. And then mapping. And then finally, we are going to be one hot encoding a couple of our values. That had small numbers of unique values. And I'm using Panda's get dummies method for this. And then for our numeric columns like age and number of years of experience, we are using PD2numerics method and coercing any errors, which will cause us to have some null values that we need to take care of. Okay, and now for our high cardinality with dev types. Remember we had like, I think 33 different types of developer. We're gonna just keep the top 10 here and group the rest as other, kind of similar to what we're doing for country. Which will be here. So we had 140 unique country values. We're gonna keep the top 15 and group everything else as other, and then get dummies for each of these kind of reduced complexity variables. I know this is a lot. I know this is a lot. We're doing a ton of data cleaning here. Ton of transformation. All right, and now just a couple print statements at the bottom so that we can get a very good log of all the work we did here. Okay, so simplified employment, we now have just 4 different unique values. Numeric columns check, everything is looking great for our years of experience. Column types, this is great. We don't have any more object column types. Everything is numeric. We are doing great. Remember I said we're going to introduce some null values when we coerced our errors. So here they are. We have a handful of null values we'll need to take care of. Okay. So let's go ahead and drop those null values. We have done a ton, and I want to address questions. So we'll pivot to that now. Christian, you're really interested in this data transformation. Me too. It was so fun for me when I was kind of creating this project to start with 90,000 rows of survey information, which survey information is like the most dirty type of data you can get because it's just people sharing, right? And it was very fun to go through. So because there was so much cleaning we had to do, let's pause here. And next week, stay tuned for an email about next week's webinar. Um, we'll do the machine learning component where we talk about correlations. We have a little bit of multi-collinearity we have to talk about. And then their model results, which, you know what, are pretty exciting. So yes, I will pause for questions now. Let's start with the Q&A. So if you do have questions for me, pop those in the Q&A and I will start looking there. Okay. Timothy asks, where can you get the slim data set? That was asked pretty early in the webinar. So I do hope that I answered that in the DataQuest app. You can see survey results underscore slim here. You can download those. But basically what we did from the original data set, I can show you my code for that actually. I knew what columns I wanted to drop, so I had AI help me with that. Um, Basically, the slim data set removes nulls from our target, as well as response like survey metadata stuff, redundant compensation columns, aspirational tools that aren't actually indicative of what someone is already working with, things about Stack Overflow, how people feel about AI rather than what they're actually doing with AI, and then some kind of oddball questions here. So hopefully that answer, Timothy, you got it. Awesome. Then Timothy's follow-up, are the salaries in the same currency? Yes. I always am a huge advocate of going to the data source to learn about your data set. So this is the Kaggle page for this survey. And you can see they have schema information. They have the actual survey questions that were asked, if you want to take a look at those. And then the README gives a little bit of explanation about things as well. So the target variable we're using is everybody's individual compensations converted into US dollars. And Praharsha asks, is there any other way to deal with outliers instead of keeping some cutoffs for salaries? Yes, yes, there are better ways to deal with outliers, potentially better ways to deal with outliers. You could do some kind of calculation. The name is escaping me right now. But I would consider on your non-trimmed data looking at like a box plot and seeing if there's anything kind of outside of your like IQR in interquartile range. That would be easy removals. So yes, cutting outliers off by an arbitrary cutoff, there are definitely better ways to handle it than that. Tamsir, I'm seeing your question. You're getting an error with a key error, learn code and OPSIS professional use not found. So sometimes when you remove columns in a Jupyter notebook, so for example, I'll look at my cell 4 where I dropped a bunch of columns. If you rerun this, let's do it. Let's see what happens. Um, I'm shocked that didn't break. Um, but usually when you rerun dropping after you've already dropped, you get an error saying, we can't find that column to drop because it doesn't exist anymore. You've already dropped it. So rerunning can cause an issue. Maybe that's what happened. Let me know. Oh, I just see your follow-up. Never mind, you figured it out. So what I do in those situations, by the way, is I just restart my entire kernel with the double arrow here. And that resets everything to its original state and will have all of your cells flow one to the next. Hmm. And Bargavi asks about get dummies. So yes, I can spend a little bit more time on the get dummies method because it's so important for understanding in machine learning. Um, okay, so here's what I'm going to do. We're going to look at the head of our data frame. And yeah, country. So we use the get dummy method on our country column here. And so what is happening when we use get dummies is it's taking the individual country names from one column and expanding them out sideways. So each country has its own column. So Italy has its own column, Netherlands has its own column, everything we clumped together in other has its own column, Poland, so on and so forth. And the great thing about this is we get to keep the information of what the value is for that row of information. So this person, their country was United States, and everything else is false because their country value was United States. So we still get to keep the information that they live in the US, but true is a value of 1, false is a value of 0. So we have converted a single column into many columns, making each one numeric. Hopefully that made sense. I think this visual is very helpful. So you can see that every single row only has one true value for country. And if you don't see a true value, it might be cut off here in the dots. But country will only have one true value. One true, one true. And that's the main principle of get dummies. And Bidu asks, how do you study the concepts discussed in this analysis as a beginner? I highly recommend, I mean, I'm biased, but I highly recommend DataQuest's machine learning course. So I can show that to you. Nope, that's not going to do anything. There we go. And if we go to our dashboard, I have the dashboard in, it's in the data scientist path. I think version 2.7 is the most up to date. And in section 8, machine learning in Python, these introduction courses, introduction to supervised machine learning, introduction to unsupervised machine learning, are phenomenal because it doesn't actually start with scikit-learn. It starts with what are the concepts that scikit-learn used to build their methods. So that's my recommendation. I can share a link to the first one I mentioned in chat. There we go. There you go, everyone. Okay, we have a couple more questions. I think we're gonna end right on time today. Um, If we drop columns, Hinnock asks, if we drop columns that are nulls after training our model, can we use it on incomplete inputs that may have some null values? Nulls do not work well with machine learning. So that's why my final step here, after we did create some nulls in our numeric coercions, that's why I removed them. Because machine learning, when it's trying to calculate the interactions between different values, if it sees a null, it doesn't know how to calculate on something that's missing. So you do have to take care of those null values. Uh, Benjamin asks, without looking at the solutions notebook, would you recommend a beginner to use generative AI tools to learn how to complete data pre-processing, etc., drop high-value columns? I would not. I highly recommend, or I highly caution against using generative AI to help you understand the workflow of a data project until you understand what the workflow is yourself. Because as I was writing this project and using my AI assistant to help me generate the code, it came up with some bananas ideas. And I had to push back against it and say, hey, that's not a good idea. That's going to lose a lot of our data. That's going to create bias, et cetera, et cetera. And I wouldn't have known it was incorrect if I didn't have my foundation in the data process first. So if you're a beginner, I think AI is most valuable for if you get a traceback error. So for example, if I'm just going to make an error on purpose here, if you get a traceback error like this, copy and paste this into AI and say, hey, what's going on? Why is my code breaking? Explain it to me. And that's going to get you the foundational skills you need to then later down the line use AI as a heavier hand. And Emma, how do you get access to the YouTube video? I need to process that today. And once I do, we'll send you an email with the YouTube link, and it'll be within the next 24 hours or so. Okay, we had questions. We're ending just a couple minutes after, so I'm going to call it on time. So thank you all for coming. I do apologize we had to split this last minute into a part two, but the project was just too good to keep in one part, right? So stay tuned to your inbox for an invite to part two, and this part will be up on YouTube soon. In the meantime, you have a week to play and explore with a brand new DataQuest project. So go check it out, look at the solution code, use some AI to explain the syntax parts you don't understand, and come prepared with lots of great questions for next week. Yes, thank you everybody for tuning in. I do hope to see you back next week. All right. Bye, everyone.